Graphs of functions. So we have this vertical line test to determine whether a graph is a function or not. It says if any vertical line intersects the graph in more than one point, then the graph does not represent the graph of a function. So here we have two graphs, and the vertical lines test is still above here. So in the case of this first graph, I notice that there's a specific vertical line, this one right here, that intersects 2 points, -2, 3 and -2, 4. Because this vertical line intersects 2 points in the graph of this relation is not a function. Because what we have here is we have an element of the domain, -2, an x value, that is actually assigned two different elements of the range, 3 and -4, two different y values. So this relation is not a function. On the other hand, for this relation over here, when I take a look at this rectangular coordinate system, no matter which vertical line I draw that goes through one of the ordered pairs, it goes through one and only one ordered pair. It doesn't go through more than one ordered pair. Therefore, because every vertical line that you can draw that goes through an ordered pair only goes through one, this relation is a function. All right, now what if instead of having just the ordered pairs in a discrete graph, what if we had a curve? So let's take a look at these two curves here. These are both parabolas, but one of them is not a function. This one over here, if you draw a vertical line that touches most of these points, that vertical line will also touch another. So here's a specific vertical line through -4. Seems like we have the value -4, 1.02 roughly, and -4, -5.02. So those two ordered pairs are on the graph of this relation, but they're also on the graph of a vertical line, meaning they have the same x value. Therefore, this relation is not a function. It doesn't pass the vertical line test. On the other hand, for this second parabola, no matter which vertical line you draw, the ordered pair gets intersected and no other ordered pair gets intersected. So if you draw a vertical line that intersects an ordered pair on this second graph, it intersects one and only one ordered pair every single time. Therefore, this relation is a function. So now let's talk about the domain and range of a relation that's given as a graph. So let's take a look at this function here, and let's find the domain and range of this graph. Well, if you haven't watched the video on interval notation, you might want to give that video a watch. So because this goes all the way to the edge of the graph, I can assume that it continues on in that direction. So I'm just going to assume that it keeps going in that direction, meaning it keeps going to the right in the positive x direction, and it keeps going downward in the negative y direction. All right. So to look at the domain, I'm going to talk about the x-axis. And along the x-axis, I'm going to look for a point that's furthest to the left. This point here is the furthest point to the left, and I note the x value of that point. X value of that point is -3. Then I try to look for an x value for the point that's furthest to the right. So I'm going to the right and I'm saying, where's the ordered pair that's furthest to the right? But because this arrow means this thing keeps going to the right forever, it means there is no ordered pair that's furthest to the right. They're ordered pairs as far right as you want to go. So if you keep going right, there will still be ordered pairs. That means the domain, while there is a minimum x value, there's a smallest value that x can be. There is no largest value that x can be because the ordered pairs keep going as you go to the right. This creates an interval that begins at -3 but doesn't have any maximum. So the minimum is -3 but there's no maximum. This is that interval from -3 to infinity, including -3. So that's my domain. X can be any of these numbers on this interval, basically any number greater than or equal to -3. So that's the domain. Now let's talk about the range. So we're going to do the same thing, except we're going to do it from bottom to top. I look for an ordered pair that's the one furthest to the bottom, the lowest ordered pair on the graph. But this arrowhead means there is no such ordered pair. There is no ordered pair that's the lowest on the graph. But there is, however, an ordered pair that's the highest one on the graph. This is as high up as the graph goes. And that ordered pair occurs where y is equal to 2. So I mark that on the y-axis. And then I look at the fact that there is no minimum y value because the ordered pairs go down as far as you want to go. And that means that my range actually consists of the interval that has no beginning but ends at positive 2. That's this interval here from negative infinity to 2. There is no minimum y value, but the maximum y value is 2. So that's the range. That's the range. All right, let's take a look at another example here. This example, there are no places where this thing goes all the way to the edge of the graph. Therefore, this thing is confined in all 4 directions. There's going to be a minimum x. There's going to be a upper bound for x. There's going to be a lower bound for y. And there's going to be an upper bound for y. So first, we look at the x-axis to find the domain. We look at the x-axis and I say, where's the point that's furthest to the left on the graph? There's the point that's furthest to the left. The point that's furthest to the right is this point right here, but you notice that point is an open circle. So even though the point furthest to the right has an x value of 1, that point is not actually included. So I put an open circle there on the x-axis. And I'm looking at the fact that there's ordered pairs between negative 2 and positive 1. So I'm looking at the interval between those two values, and I need to describe that interval using interval notation. Well, that means negative 2 is going to be included, so I'm going to use a bracket for negative 2. But because there's an open circle here, positive 1 is not included. So I'm going to use a parenthesis for positive 1, and there's my domain. Now let's talk about the range. So now I'm looking from bottom to top. So I'm looking for the lowest point on the graph, which is this point right here, which has a y value of 0. And I'm looking for the highest point on the graph, which is this point right here that has a y value of 4. So I mark that on the y-axis. They're both included because neither one has an open circle. And then I need every point in between because there's ordered pairs between those two y values of 0 and 4. So I'm looking for everything in between here. And because they're both filled in circles, I'm going to use bracket for both 0 and 4 for the range. So the range is from 0 to 4. And there's my domain and range for that graph. Now we're going to talk about a specific type of function and how to find its domain and range, and also how to graph it. So the type of function we want to talk about is called a linear function. So the linear function with slope m and y-intercept 0b is f of x, which is just the y value assigned to this specific x value, but f of x is equal to m times the x value plus b. So the value that gets assigned to each x value is the slope times that x value plus b. That's how you come up with the equation of a line. This is a linear function. So, what is the domain of a linear function? Well, if you take a look at the graph, this arrowhead points to the left, meaning there's no minimum x, and this arrowhead points to the right, meaning there's no maximum x. Therefore, the domain of a linear function is negative infinity to infinity. No minimum, no maximum, no lower bound, no upper bound. On the other hand, the range of a linear function depends on the slope. If the slope of the linear function is not 0, meaning it's slanted in some way, then it's eventually going to cover every y value from bottom to top. And in that case, the range of a linear function is also negative infinity to infinity. So both the domain and the range of a linear function whose slope is not 0 is negative infinity to infinity. On the other hand, for a linear function whose slope is equal to 0, there's only one y value because it's a horizontal line, and that y value will be the only y value in the slope. So the only y value, and that y value will be the only y value in the range. So it's just one single value in the range. In order to give that as an interval, you just start the interval at b, end the interval at b, and include b by using brackets. So here's an example. This is a linear function. F of x, which is y, equals m times x plus b. So m is 2/5, that's the slope, and the y-intercept is the point 0b. So this is a linear function, mx plus b, as you can see. Slope is 2/5, the y-intercept is 0.3. Once you identify it as a linear function, then automatically we know what the domain is. The domain is just -infinity to infinity. So I have the domain. And all we have to do to figure out the range is figure out if the slope is 0 or not. In this case, the slope is not 0, it's 2/5. So that's non-zero. And in the case where the slope is not 0, the range of the linear function is also -infinity to infinity. All right, so let's go ahead and find some values for this linear function. Let's find some assignment values. So here is saying, given this linear function, what's the f of 5? Basically, what y value gets assigned to the x value of 5? So I plug in 5 for x. When you plug 5 in for x, you have to multiply 2/5 by 5 over 1. And then 2 times 5 gives you 10 over 5 times 1 is 5. So that's 10 over 5. And 10 over 5, well, 10 divided by 5 is 2. So that's the f of 5 is equal to 2 minus 3. And 2 minus 3 is -1. So I have that the f of 5 is -1. That's the ordered pair 5, -1. All right. Let's find another one. That's the f of 5. Let's find the f of 7. So we do the same thing. We plug in 7 for x. That's 2/5 times 7 over 1. 7 times 2 is 14 over 5 times 1 is 5. That's 14 over 5. In this case, I need a common denominator. That's 3 over 1. The common denominator here is 5. So I'm going to multiply the top and bottom of this second fraction by 5. After I do that, I'm going to get 3 times 5 is 15 over 1 times 5 is 5. So I get 14 over 5 minus 15 over 5. Now that they have the same denominator, I can subtract 14 minus 15 over 5. That means that when x is 7, y is -1/5. Y is -1/5. So I have another ordered pair, 7, -1/5. And let's try one last one. Instead of 7, let's plug in 0. So let's find the f of 0. So when we plug in 0 for x, we get 2/5 times 0 is 0. 0 minus 3 is -3. So that the f of 0 is -3. That's the y-intercept. The ordered pair 0, -3. So the ordered pair 0, -3 is the y-intercept. Let's graph the function then. Now that I know the y-intercept is 0, -3, I can graph this thing by plotting that ordered pair 0, -3. There it is. And now from this ordered pair 0, -3, I know that the slope is 2/5. So I'm going to rise 2 and run 5. And that's going to take me to another point on the graph. So there's the second point on the graph. Once you have that second point on the graph, all you have to do is connect the dots. We connect the dots, we get this line right here, and this is the graph of that linear equation. As you can see, all the points are there. We got 0, -3, which is an ordered pair I found. We got 5, -1, which is an ordered pair I found. We got 7, -1/5, I think it was, which is an ordered pair we found. And there you go. All those ordered pairs are on the line that we drew, and that's how you graph a line. Now let's take a look at this last example. Given this function, f of x equals 4, find the domain. Well, looking at this one is also a linear function. If you write it as 0x plus 4, means the same thing. And now we see that this is a linear function whose slope is 0. mx plus b, m is 0, b is 4. So since it's a linear function, the domain is going to be negative infinity to infinity, just like all linear functions. And now we can find the range. Now there was a different rule for the range when the slope was equal to 0. If the slope of your linear function is equal to 0, then the range of the linear function is just b. In this case, b is the number 4. So the range of this linear function is just the number 4. And as an interval, that would be just 4 to 4, including 4. So that's just the number 4. And that would be the range of my linear function. Let's go ahead and do the solid of graphing it too. Let's graph it. So once again, we can graph the y-intercept. The y-intercept is 0, 4. 0, 4 is the y-intercept. And the slope is 0, which means I'm going to rise 0, but I'm going to run as much as I want. So there's no rise. The rise is 0, but the run is as much as you want to run. There's another point. We know it's a horizontal line with no slope. So we connect the dots to draw our horizontal line, and there is the graph of this second function.